Next is about the phasor diagram. What is a phasor diagram and what is the use of the phasor diagram? Phasor diagram is the diagrammatic representation. And in that diagrammatic representation, what is it? We are considering this alternating EMF, E and alternating current as vectors. And those vectors are rotating vectors. Okay, rotating vectors. With respect to this origin, if they can rotate or it can move with a same velocity, that is angular velocity omega, such representation it is known as the phasor diagram. So phasor means it is the vector representation of any quantity. Okay, here we are taking it as the EMF and current because our chapter is about the alternating current. So this EMF and current as the vectors which can be rotate, which can move with an angular velocity omega. Such representation it is known as the phasor diagram. These are phasors, that is the vector. Here you can see that the vector OE. That is a vector which is representing this alternating EMF, and OI is a vector which is representing the alternating current, that is AC. And here both are rotating with an angular velocity omega. And both of them are keeping a phase difference of phi. Both the phasors are keeping a phase difference of phi, that is a constant phase difference throughout this rotation. Okay, and here the length of the vector represents its magnitude of this EMF and current. So here I have drawn this OE is greater, length of OE is greater than OI. That is, the voltage is or the EMF is greater than the current. So the magnitude of the voltage is greater than that of current. So the length of the phasor, which phasor, that is the voltage phasor, is more than the length of the current phasor. So we can represent the relation between the voltage and current as the rotating vectors, and that vectors are known as, or that diagrams is known as the phasor diagram. It is very important. What is the importance? That is, now after this we are going to discuss about the phase relationship, or what is the relationship between the voltage and current. There is an alternating current when it flows through the circuits, that is electric circuits which containing all the electrical components. That is, first we will study a circuit containing only a resistor. Okay, when electrical circuit, it consists only a resistor. So when AC passes through that, what is the relationship between this voltage and current? Next we will study a circuit containing only an inductor. Inductor we know which provides inductance. And next we will study when AC flows through a capacitor. Capacitor, you know, it's a device store charges. Then next we will study all these three are combined. That's a series combination of all these things. In all such cases, how this voltage and current varies. Is there any relationship between this voltage and current other than the equation? In the case of DC, we know what is it, 5 volt flows for a time 5 seconds. We know what is the current. Okay, so that will be a constant current. Only there is a difference in the magnitude, that is the voltage and current. But here it is not like that. It is sinusoidally varying each and every time. What is it? The magnitude of the EMF is, that is the voltage is varying. Same way there will be a current also varying. And is the variation, that is the voltage current variation, is it constant as in the case of DC, or is there any difference? And how is it same for all the cases, that is in the case of resistor, capacitor and inductor. So all these things we are going to discuss. For that, this phasor diagram, it is very important. So phasor diagram, what is it? It is the diagrammatic representation of voltage and current. Okay, voltage and current in the form of vector which can be rotated with an angular velocity omega. Okay, graphical representation. So we will use, no need of studying the definition and all, just have an idea about this phasor diagram. So using this phasor diagram, we can easily represent the phase relationship between this voltage and current. So now we are moving to the first circuit, that is the AC circuit. That is an AC circuit which containing only a resistor, that is electric circuit. In that circuit, imagine only a resistor is connected. Okay, and we are giving that it is connecting to the plug point, and what is it? An EMF, that is the alternating voltage will flow through that. And how the current produce? What is the relationship between the voltage and current? Is it obeying this Ohm's law, and how is it obeying? And such circuit, it is known as the purely resistive circuit. Only a resistor, it is known as a purely resistive circuit. Okay, so here we require the phasor diagram, here we require the graphical representation, and we are going to study what is the phase relationship between the voltage and current. Is it similar to DC? Okay, so here this is the diagram, that is what is it? I have considered a resistor. This is the resistor. You know how to represent a resistor, and its resistance is R, and it is connected across a voltage source. That is the alternating voltage source, and this is the symbol. Okay, alternating voltage we are representing by this symbol like this. This is the AC variation cycle. Okay, alternating, and DC voltage source we are representing by this battery, isn't it? And here this is the representation of the DC source, and this is the representation of an AC source. Okay, remember that. So here what is it? It is connected, and from the supply we are getting a voltage of V equal to V0 sin omega. We know that. Okay, where V is the voltage, instantaneous voltage, and V0, you know what is it? V0 is the peak voltage or the maximum voltage, and omega is the angular frequency. Okay, angular velocity frequency, and T is the time. Okay, T is the any instant of time. So at any instant of time we can find out what is the value of V. And if it flows, you know there will be a current, isn't it? Current we are taking it as I. And here this is a closed loop. This is a closed loop. In this closed loop, according to Kirchhoff's law, that is the Kirchhoff's law, loop law, or Kirchhoff's second law, what is it? The applied potential is equal to the sum of the product of current and resistance. So here what is it? Applied. What is it? The applied will be equal to what is it? The sum of the difference. Sum of the potential difference in the closed loop. Closed loop. That is the Kirchhoff's, according to Kirchhoff's second law. It is also known as loop law. Kirchhoff's loop law. Okay. So what is it? What is the applied voltage? It is V is equal to V0 sin omega t is equal to product of current and resistance. That is the potential difference. So what is the current here? I, and what is the resistance here? R. So we can write it as IR. That is according to Kirchhoff's second law, or Kirchhoff's loop law. R. From this we can write the equation for I. We have to find out what is I, because V we know, potential we know, so we have to find out I. So we can write I equal to V0 sin omega t divided by R. I equal to V0 sin omega t by R. And we know that V0 is a constant and R is a constant. So V0 by R, we know it is equal to I0. So instead of V0 by R, I am writing it is I0 sin omega t. I0 sin omega t. I am taking this as equation 1, that is the applied potential, and this is the equation 2. Okay, what is it? Here we connected AC source, V equal to V0 sin omega t is the applied potential, I is the current, and R is the resistance. And we are just using this loop law here. So according to that law, we are getting this, and we are getting equation 1 and 2. Equation 1 is V equal to V0 sin omega t, and equation 2 is I equal to I0 sin omega t. We can compare. This is the applied potential and this is the current passing through the resistor. Compare this equation 1 and 2. And we can represent this 1 and 2 graphically. We know how to represent it graphically. Okay. So in a single diagram, we can represent. So here it is omega t. So your value comes 0, then 90, 180, 270, 360. We can go for one cycle. Okay, omega t. And here this is E0 and here it is minus E0 and I0 minus I0. So first we can plot this E0 or take it as E0. Okay, we can plot for this first equation, omega t. So omega t 0 means, what is it? Sin 0, 0, point comes here. Omega t 90, then 90, sin 90 is 1, we know. So we will get the point here. Sin 180 again 0, 278 is minus 1 and 360 again 0. So this is the representation of what? Representation of the voltage. Yeah, graphical representation of voltage. And current, we can represent current. What is it? Current I equal to I0 sin omega t. Omega t 0 means, where is the point? Here will be the point. It will be maxima, it comes here. 180, 0. Then 270 minus 1 and 360, 0. So joining the point, you will get the curve like this, isn't it? So what is the conclusion from this? Here, when an alternating voltage passes through a circuit containing only a resistor, there is a current, that is I equal to I0 sin omega t, and the variation in the current and voltage is same, isn't it? So voltage 0, current also 0, voltage maximum, current also maximum, again 0, current also 0, negative maximum, both comes negative maximum, 0, both comes 0. So such case, we are saying that here the voltage and current are in phase. That is, we know what is in phase and out of phase. Like, same thing. The variation is same. One maximum, next is also maximum. One minimum, next is also minimum. 0, both are 0. So what? Nobody is leading or lagging, isn't it? So here the conclusion is, in a purely resistive circuit, voltage and current are in phase. Or we write the phase difference. Remember, phase difference phi is equal to 0. Is there any difference in phase? No. So we can write the phase difference phi equal to 0, or in phase, or the phase difference is 0. So that is the important result. What is it in the case of a purely resistive circuit? It's just like a DC circuit, only there is a variation in the magnitude. Okay, so peak and maximum, minimum, that variation is same in the case of a purely resistive circuit. And here this resistance, we can write how we got this, that is Vi is equal to E0 by R sin omega t. So I0 is equal to what? It is equal to E0 by R. So here comparing with the Ohm's law equation, that is I is equal to V by R. What is this R? R is the resistance. So here also R is the resistance here which we used, and it is the opposition for the AC in a purely resistive circuit. Okay. So what is the conclusion? In a purely resistive circuit, very important, in a purely resistive circuit, both the voltage and current are in phase, or there is no phase difference between the voltage and current, and the opposition offered by the circuit, it is known as the resistance. This is the graphical representation. Next we have to go for the phasor diagram. We studied phasor diagram. So what is that phasor diagram? Here we can consider this voltage and current as a vector. So in the coordinate system, what is it? Both the vectors, like we can consider the voltage as a vector and the current as a vector. So both are rotating with the angular velocity omega. So here we can represent this as the voltage V, and this is the maximum value V0. X-axis, x dash, y dash. So here it is rotating with angular velocity omega. Where will be the position of current? They are moving the same pace, one over the other. So what is it? We can represent current over this. This is the current. Why arrow here? Because the magnitude of current is less than that of the voltage. So here the maximum comes here. That is I0. Okay. So both will rotate together with the angular velocity omega, and this is known as the phasor diagram. Phasor diagram of a purely resistive circuit, and this is the graphical representation of variation of voltage and current in the case of a purely resistive circuit. Okay, so what is it? Phasor diagram. Phasor diagram, it is the vectorical representation, vector representation of the voltage and current. Okay, any quantity it is rotating with an angular velocity, we can represent it as a phasor. And next up, the first circuit which we are considering, it is the purely resistive circuit, only a resistance in that circuit. So in such cases, what is the relation? Both the voltage and current are in phase. Very important one, in phase, or the phase difference represented by phi is equal to 0. We studied phase difference and all. And this is the graphical representation. So it is very clear from the graphical representation, and this representation is known as the phasor diagram. So this is the one mark question, that's the graphical representation and the phasor diagram. And what is the opposition offered is called, it is known as the resistance. Okay, so that is the case of the purely resistive circuit.